we're going to examine the acceleration due to gravity. So right now, we know the acceleration due to gravity on the surface of the Earth is 9.8 meters per second squared, right? That's what little g, right? Little g represents the acceleration due to gravity. So anyway, little g is acceleration due to gravity, and on the surface of the Earth, it's 9.8. But if we were to move farther away from the surface of the Earth, what would the acceleration due to gravity do? What do you think? Would it go up or would it go down?
Down.
It would go down, right? As we get farther away, like if you're on the top of Mount Everest, right? We're still on the surface of the Earth, but we're higher. The acceleration due to gravity is like 9.77, right? So we see a little bit of it. Do our things start floating on the top of Mount Everest? No. But when we get all the way out to like the moon, acceleration due to gravity is only like 1.6, 1.7. So we see a big decrease. And so now we're going to be able to calculate the acceleration due to gravity, or little g, at any point on any planet, right? Using this equation down here at the bottom. Okay, so this is just kind of a progression of walking through how did we get from this equation that we already know, Newton's universal law of gravitation, down to this new one for the acceleration due to gravity. And so really what happens is that we took Fg and we plugged in one of the masses to be the mass of the Earth. The other mass is the mass of the object. And then we took mg, or the mass of the object, times the acceleration due to gravity, and just substituted it in right here, right? M, mass of the object, times the acceleration due to gravity equals that. And then the last thing we did is just cancel m2 on both sides, and it leaves us with this equation. So now, using this equation right here, we're able to calculate the acceleration due to gravity at any radius, at any point above the Earth's surface, okay? So this equation right here, I do think it needs to go on your equation sheet. Okay, and we have to remember the difference between little g, which is acceleration due to gravity, and then Fg, which is force of gravity. So two different things. Okay, so let's go ahead and get that on your equation sheet, and then we will we'll keep working through what that looks like. Okay, so this one says, what is the acceleration due to gravity on the top of Mount Everest, which is 8,848 meters above the surface of the Earth? Now, when we look at our equation, G equals big G times mass of the Earth over R squared. We have to remember this R value is the distance from the center of the planet all the way to my object. So if I come over here and I draw the Earth, here's Mount Everest, right? Here's where we want to find the acceleration due to gravity. So the radius that has to get plugged into our equation has to be from the top of Mount Everest to the center of the Earth. Okay, that has to be that total distance. So that means to find the radius that's going to go here, I have to go 6.38 times 10 to the 6, because that is the radius of the Earth, plus 8,848 meters, right? Plus the height of Mount Everest. Does that part make sense? We have to add those together before we can put them in as our radius. Okay, so let's go ahead and plug that into your calculator. And then we have to make sure that we don't want to abbreviate it back down into scientific notation, because then it's going to look like we didn't do anything, right? So 6.38 times 10 to the 6th, or you might have stored it as R, plus 8848. Still gives me 6388848, right? And so I don't want to just rewrite that as 6.38 times 10 to the 6, because then it looks like I didn't add anything to my radius. All right, so I want to keep that whole number when I put it into my equation. All right, so little g, that's what we're solving for, equals big G times mass of the Earth over 6388848. And then I have to square that value. Okay, are we good with having both of these numbers in our calculator, right? That's why I'm not writing them out, because we've got both big G and M in our calculator. Okay, so I'm going to go ahead and keep that number I have right there. I'm going to square it. Then I'll take mass of the Earth divided by that answer. And then I'll take that times G. And let's see what we get. I want you to run that in your calculator to make sure that we can get that to come out to what we should get it at. this one says if two objects have equal mass, and they say, actually, this is a force due to gravity problem. Let me see. Okay. Yeah. That's all the practice problems I have with that equation. I'm going to make up another problem for acceleration due to gravity. Okay. So we want to say, what is the acceleration due to gravity at a distance of 2.14 times 10 to the fourth meters from the Earth? Okay. So again, we're going to go little g equation because that's what I'm solving for. Acceleration due to gravity is little g. Big G, mass of the Earth over r squared. Okay, so what do we need to do with this 2.14 number? Any ideas? We have to add it because if there's my Earth, there's my object, right? This distance is 2.14 times 10 to the fourth, but I know I need this distance to go into my problem. So I've got to add those together. So my radius is really going to be 2.14 times 10 to the fourth plus 6.38 times 10 to the sixth. And so that gives me a radius of 6.401400. Okay, and once I've got that done, now I can just go ahead and plug it in. Okay, G equals big G, mass of the Earth over, and I got to square that radius. So since my number's already in my calculator after adding it right there, I just go ahead and hit squared, and then I go alpha m divided by the answer. Then I take that times alpha g. Right, and I get an acceleration due to gravity of 9.73. Okay, so now I'm asking the question, at what height above the surface of the Earth is G equal to 6.49 meters per second squared? Okay, so let's draw out our little picture here of the Earth again, right? If here's the Earth, here's my object. This is the distance I want to find out. Right? At what distance, at what height above the surface of the Earth is G equal to that value? So in order to do that, I really, right, if I know my radius that goes into my equation is that whole distance, what I'm really going to do is I'm going to solve for r, and then I'm just going to subtract out the radius of the Earth, right? Because I know the radius of the Earth, and I know that the value that has to go into my equation is the full distance. And so if my goal really is only to find that question mark, I'm going to subtract out what I know about the radius of the Earth, but I'm going to wait until the very last minute to do that. I don't want to do that early and put in a variable minus RE. That's just too much work for me, right? So let's just go ahead and solve first for the radius, okay? We know that G is equal to 6.49 equals big G times mass of the Earth over r squared. Okay? So it looks like we don't have very many numbers, but we do have this one and we do have this one, right? They're just stored in our calculator. So let's go ahead and say, algebraically, what's the first thing that I would do? Okay, you could do that. You can multiply those two together. Okay, so we can go ahead and do that. So we go 6.49 equals, okay, so take G times ME in your calculator. And we get 3.98 times 10 to the 14th over R squared, right? All right. So now if my variable is in the bottom right here, do you remember the trick for solving for this variable if it's in the bottom?
Multiply both sides.
Yeah, we're going to multiply both sides by R squared, and that will move it over. But then we'll have to move over 6.49. All right, we're going to have to divide over 6.49. So the shortcut here is just to trade these two spots, right? It would end up being R squared equals 3.98 times 10 to the 14th over 6.49. So then I can go ahead and do that math, right? My 3.98 number is already in my calculator. So I'll go divide by 6.49. And that gives me R squared equals 6.146 times 10 to the 13th. And then I want R by itself. So do you know how to square root with your calculator? Second square root, second answer. And so that gives me an R equal to 7839550. And so is that my final answer?
You have to subtract.
I have to subtract, okay? Because this is my total distance, right? But I really only want that. So I need to subtract out the radius of the Earth, which is 6.38 times 10 to the 6th. And so now I get a distance or a height of 1459550 meters.